Hi, my name is Ruben Rubio, and I'd like to talk to you about science education, hoping to interest some of you in going through some PD in science education with myself and my colleague, Tony Hembrock. So I thought I'd maybe talk a little bit about what we'd be doing if you're interested in doing science education. And if you are either elementary or secondary, that doesn't matter. We can work with you either way. I've worked with both over the years, so that's not a problem. Sometimes teachers have some doubts about their ability to do a good job teaching science. And some of that comes from some doubts about whether you understand the science yourself. And I get that. And so one of the things we'll be doing, this is not Bill Nye the Science Guy coming in to dazzle you. This is an attempt to have you do some simple but approachable things that you can do and that have some research basis that will get some results in your science classroom. So let's talk about some of the things that we'd be looking to do. So one of the things we'll talk about is the Next Generation Science Standards. And these came out in 2013, and you can get to it through that URL. And the Next Generation Science Standards were developed with the idea of really changing science instruction so that it matches science practice. And that's one of the things you see a lot of. For example, there's the old stereotype about the geeky scientist who doesn't know how to communicate, doesn't know how to write, doesn't know how to talk. That stereotype is out the window because scientists in the 21st century have to be adept at communicating. We've kind of thought about someone like Einstein who goes off by himself and imagines these great things and then comes out and shares them with the world. Well, in actuality, scientists build on each other's work quite a bit, and Einstein built on other people's work as well. He may have seen a few things that others didn't see, and even 100 years later, the Nobel Prize that was just announced recently verifies some of the things that Einstein talked about. But it was a very collaborative enterprise that he did, and he built on the work of others, and that's how science is. So the Next Generation Science Standards, if you take a look at those and just kind of get yourself familiar, this is something that we'll use as one of our things that we'll talk about in our time together. For example, the Next Generation Science Standards have the basic ideas that we're kind of familiar with, core ideas from physical science and life science and earth and space science, and also the STEM activities. So that's kind of been something that's been part of science. It still is part of the Next Generation Science Standards. Where things get kind of interesting is, if you look at this diagram over here, you see those core ideas are represented here in the middle. But up above are these things that are called practices. And this is sort of saying to approach science the way a scientist does. And these are some of the aspects of approaching science the way a scientist does that we would talk about. And it would be part of your approach to teaching science and also part of the approach that your kids would take in doing science. And we won't even use the word scientific method because scientists don't always use a scientific method, but they do use a logical path to figure out what's going on, and they use some of these practices. Here's a freebie for you, even if you don't do the science education. If you want to get the most mileage out of experiments that you do with your kids, have your kids do a prediction. That's this part here in red here. Have your kids do a prediction of what's going to happen before you start, and then revisit that prediction after the experiment is over. And in some of the things I've looked at and I've experienced in my teaching and my research, that's one of the things that makes a big difference in whether something sticks in someone's head, is they can predict what's going to happen, and then they revisit that prediction and see if they were correct or not and have an explanation either way, why they were right, why they weren't right. The next interesting thing about the Next Generation Science Standards is something called a learning progression. And this is kind of a newer thing. I'm not sure when some of you might have gone through a teacher preparation program or if you have ever gone through a teacher preparation program. But the learning progression, you can think of it as sort of like a series of building blocks. And the building blocks say you have to know this before you know this. You have to know this before you know this. And the idea is to identify what those blocks are. So you know this is the basic knowledge, this is the knowledge that builds on, this is the knowledge that builds on that, etc. And then you can do assessments along the way and see, did they get the basic thing? Did they get the next level? Did they get the next level? So that's the nice thing about learning progressions. The learning progressions are built into the Next Generation Science Standards as well as other standards that have come about in this decade. So we'll talk a little bit about learning progressions and why those are useful for teaching and learning. The other thing is this interesting idea of cross-cutting themes in science. And some of these, if you look at them, there's like a tension between them. They look like stability and change. How does that work? Well, they have a tension with each other. And sometimes you have to see how those themes play out in life science, how they would play out in physical science, how they play out in earth and space science, how they play out in STEM. And that's kind of the idea of seeing these cross-cutting themes as they reappear in each of the core areas of science. So we'll talk about that and sort of understand what the goal is in science learning for, again, for teachers and for students. And then we'll use that as our building blocks for what comes after that. Another thing that I think we will want to talk about is what I would call the harmony between our Christian faith and science. And sometimes people don't see that harmony. Sometimes they think, there's conflict, it's irrevocable, they're never going to be able to get along. I dispute that. I don't think that's right. So we will look at that, and especially we'll look at how there's some similarity between how a person of faith approaches things and how a scientist approaches things. There is a lot of similarity. There is some difference, but there is a lot of similarity, and we can look at those similarities as well. And then the other thing that we can do is we can just encourage each other not to be afraid to leave a conflict unresolved. Sometimes it's hard to explain why science says this and faith says that, but it's okay sometimes to have that conflict for a while and sit with it and play with it before we can try to resolve it. So for this segment of our time together, I would ask you to bring your own questions or the questions that your kids have, because sometimes those are real, they're real puzzlers. The kids think about these things really nicely, and sometimes they can challenge us with how faith and science work together. So bring those issues, bring those questions, we'll talk about those. The last thing we're going to be doing in looking at our time together in science education is sort of how the process of learning science unfolds. And there's 3 dimensions that I look at. One of them is the role of metacognition. And the role of metacognition is basically just asking students to have a realistic appraisal of their thinking. So as they're going along and trying to do something, there's a part of their brain that's also monitoring what they're doing, what they're learning, and saying, am I going through a reasonable process? Are things working out pretty well? Or am I doing this superficially? Do I need to change what I'm doing? So that's the hint for metacognition. So we'll look at the role of metacognition in science learning. The other thing we'll do is we will look at the role of motivation and this aspects of belonging and competence and usefulness and potency and optimism. And that's a very important part of learning science. Some of those you can see that people, students and teachers, have to feel like they have the agency to do this, that they are successful at doing this, and that they belong in a science classroom, and that they belong in doing science investigations. So that's another thing we'll look at the role of motivation. And then finally we'll look at the role of the learning environment. And you know, in terms of a project-based learning environment, one of the key things is to figure out a driving question or a driving problem that drives the learning. What is something that we want to solve, or a problem we want to address, or a question that needs to be answered? And then we have these other things that support that. Authentic tools of inquiry, which is afforded by technology, so we can look at things in many ways using some of the same tools, databases, etc., that scientists would use. Or when we collaborate, that's also something that's afforded by technology as well, because collaboration is a big part of science. There's not a lot of innovation that happens off in a cave somewhere. Scientists talk to each other and build on each other's work all the time, share things, dispute things, and that's what a science classroom should look like, where your kids are saying, hey, I believe this, and then that's questioned, and they have to defend why they believe it. There's no hard feelings, because in the end, the idea is that we all understand what's going on. And then things like scaffolded learning and learning progressions that I addressed a little bit earlier. And finally, an important thing is the creation of artifacts. Yep, having them make stuff. And that also can be afforded by technology quite well. So this is what we're hoping to accomplish. And here's some details of our work. So we're hoping that with these details, for starters, we're going to meet monthly via an online video conference. So we'll do that. And then you can plan to bring the questions that you'd like answered, questions about science, question about faith, questions about the nature of science, instructional questions, assessment questions. We can talk about pretty much anything. There'll be a gentle curriculum. You see I've got a kind of a structure there set up. And any homework that happens will not be this rigorous paper or anything like that. It will be something that you try out with your students, and then you come back and say, here's what happened. It's kind of cool to be able to do that. And then we will look for answers together. So this is a collaborative endeavor. But yes, I do know my stuff, and my colleague Tony Hembrook knows his stuff. So we are able to guide you in doing this. And the best part about it is free PD in science education. And what can be better than that? So I hope that you're able to join us for doing this. If, again, elementary or secondary is fine. And feel free to sign up. And I will get in touch with you, and we will set things up. That's all. Thank you for your time.